How to access and explore data from ClinEpiDB.org, a guide for students. Are you a student of epidemiology, biostatistics, or global health looking for high-quality data for a project or to analyze for your thesis? We want to introduce you to our free, online, open access data platform, ClinEpiDB. We integrate and facilitate access to datasets from global health research. For students and teachers of epidemiology, biostatistics, global health, and data science, we provide a source of rich, real-world datasets. These can be used as practice datasets to learn methods such as regression analysis, data modeling, and graphing. You can do secondary data analysis on these datasets for class projects or capstone projects, possibly resulting in publication. What is ClinEpiDB? ClinEpiDB is a free, online, open access data resource. It's developed and maintained by scientists and software engineers based at several academic institutions around the world. Where does ClinEpiDB get data? We get data from global health researchers. Study teams partner with us to make their data available. There are several reasons why global health researchers share their data. It brings attention to their work, it benefits the field, and it is increasingly a requirement for getting research grants and for publishing their data. In this short presentation, we will demonstrate first how to find interesting datasets on ClinEpiDB, then how to explore data right in the browser, and finally how to access data for download so you can work with it on your own.
In this section, we will talk about ways to find datasets that are of interest to you. Start at the homepage ClinEpiDB.org. ClinEpiDB stands for Clinical Epidemiology Database. This is a resource where you can share, explore, and visualize clinical and epidemiological data. In the header, under Studies, you will be able to scroll through the list of datasets that are available on ClinEpiDB. We host over 30 datasets and release new data every couple of months, so check back frequently. Click on the Study Summaries table to get an overview of all of the datasets. It can take a few seconds for this table to load. As you scroll through this table, you can see that we host datasets that focus on different domains, including malaria and diarrheal disease. We host both observational and experimental datasets with a variety of study designs, including cohort studies, cross-sectional studies, and randomized controlled trials. By looking at the other columns, you can get an idea of the sample size of the study, the study site, and years during which the data was collected. This column, called Study Accessibility, tells you the level of access to the data that has been granted by the study team. Some datasets are public, meaning that everyone is free to download the data without restrictions. Some datasets are controlled. You have to sign in and fill out a data request form, and then you will be allowed to download the data immediately. Some datasets are protected, meaning that you will have to fill out a data request form which will be forwarded to the study team who will then approve your request within a few days. We will discuss data accessibility in greater detail in the last part of this video when we talk about downloading data. You can click this button to add or remove columns from this table. For instance, you could add additional data and WHO indicator subdomain. This adds 2 columns to the table. Let's talk about additional data. ClinEpiDB is part of a larger family of data resources called ViewPathDB. This includes genomic resources such as PlasmoDB for Plasmodium and VectorBase for arthropod vectors of disease such as mosquitoes. And MicrobiomeDB hosts microbiome data. So this column tells you whether participants from a particular dataset have data in one of our other resources. Here, the GEMS-1 case control study has additional data on MicrobiomeDB, and it is linked here. The WHO indicator subdomain tells you more about the focus of the study, such as whether it involves communicable disease or whether it's research on maternal and child health. So the study summaries table is a good way to identify a dataset that is interesting or relevant to you. And if you see something that you want to explore further, click on the study title to learn more about the dataset, or on this Explore and Analyze icon to look at the variables. Another great way to find variables and studies of interest is to use our site search box in the header. Let's imagine that I am interested in water sanitation and hygiene. I may want to search for a term such as drinking water. This takes me to a results page. I can see search results in 3 categories: studies, variables, and variable values. Clicking on studies shows me that 6 datasets contain this term. Clicking on fields matched shows where the search term appears. In this case, it is appearing in Associated Publications, Study Description, and Study Summary. Clicking on the study name leads you to a new analysis page. Let's clear the studies filter and look at variables. We can see that a number of variable names match our search term, like drinking water source and drinking water container. We can look for categories. An example of a category is drinking water source under the term household water. And we can see that this category contains variables about various drinking water sources, such as piped into dwelling or piped into yard. Finally, you can see matches for study-specific variable information, and that refers to the contents of this table. So your search term could match the name of this variable in the original dataset or the definition of the variable. Let's clear filters and look at variable values. Here we can see that clean surroundings, boiled drinking water was one of the values of a variable called best personal vector interventions. You can click here and look at this variable in the dataset. As you can see, our site search feature is a powerful way to identify data that is relevant to you. To summarize, you can look for data in several ways, including the study summaries table, site search, or by simply scrolling through the drop-down list in the header. In every case, clicking on the title of the dataset will take you to a fresh analysis page where you can start exploring the data.
How to explore a dataset on ClinEpiDB. Once you find a dataset of interest using one of the ways we discussed, you will open an analysis. We've mentioned before that ClinEpiDB is a data exploration platform, and this analysis page is the central location from where you can do a lot of things, such as learn about the context and methodology of the study, browse through all the variables and see the distribution of each, make plots, and download the data. We're going to look at each of these in some detail. But before doing that, let's consider, why would we want to explore data before downloading it? It can take a lot of time and effort to truly understand data and whether it meets your needs. The ClinEpiDB platform is designed to help you understand the data structure, allow you to search for variables of interest, and review study documentation like the methodology and codebooks to see if a study will serve your interest. All of this will save you time down the line and help ensure you are only submitting data access requests and/or downloading data that you will use. As you explore a dataset, you may realize you only want to download a subset of the data. Using the ClinEpiDB platform, you can filter the data to the rows that you want and download your starred variables of interest to remove other variables that might add confusion due to similar names or other reasons during an analysis. With that said, let's explore one of the datasets on ClinEpiDB. Suppose I am particularly interested in exploring how rotavirus contributes to diarrhea in children. From the study summaries table, I learned that GEMS is a diarrheal disease study, and I want to explore it to see if 1. GEMS collected data on rotavirus, 2. what percent of children with diarrhea had rotavirus, 3. how rotavirus prevalence varied across study sites, and 4. what other variables of interest the GEMS dataset contains, particularly around hand washing and water usage. Starting a new analysis of GEMS, I can see that the top of the page contains a diagram showing the shape of the data. If I scroll down, I see a section of featured variables, which includes variables that are important and highly likely to be useful in an analysis. Below that, there's a search bar and more variables. Looking at the featured variables, I don't see anything on rotavirus, so I'm going to collapse this section and do a search for rotavirus. Scrolling down, I'm satisfied that this study has data on rotavirus. including its presence or absence, and information on different genotypes. Now let's look instead at what percent of kids with diarrhea had rotavirus. To get this number, I'm going to go back to featured variables and take a look at the case or control participant variable. This variable doesn't have a definition listed, and I want to know more about how cases and controls were defined. So to learn more, I'm going to click the View Study Details tab and scroll down to the eligibility criteria. Here, I can see that cases were defined as children with new, acute onset of moderate to severe diarrhea, while controls were matched on age, sex, and residence, with no diarrhea in the last 7 days. So I can use this case control variable to select only the participants who had diarrhea, or the cases. This tab offers a lot of additional information that's worth reviewing anytime you are looking at a new study. At the top of the page, you can find a short summary of the study. Below is a table of characteristics, which contains the same information as the study summaries table, such as the study design and the number of variables it collected. In GEMS, there's almost 600. We also have links to publications. While this list isn't exhaustive, it should be enough to get you started on a literature search. You can find links to other related data sets. Here, we see that GEMS has a second follow-up case control study, as well as data from 2 different community surveys. The next section gives you a summary of the background of the study and its major objectives. For instance, GEMS was done to quantify the burden of diarrhea and to identify the microbial etiology of diarrhea. That is, to understand what pathogens are associated with it. Next, we see methodological information, including study sites, dates of data collection, study design, and eligibility criteria. There's also a description of how data was collected. Here, we see that a stool sample was collected from both cases and controls at enrollment. We also provide a lot of helpful study documentation that you can download, such as case report forms. The study team is listed on this page, so even when the data is integrated on ClinEpiDB, the ownership of the data remains with the original study team. We merely facilitate access to the data. Going back to the Browse and Subset tab, I now know that if I select Case, I'm selecting only children with diarrhea. From this frequency table, I can see that over 9,000 cases were enrolled compared to 13,000 controls, which was 58% of my population. So some cases have multiple controls in this study. Looking up at the diagram, I may notice that it looks different now. Instead of pink stretching across the bottom of each box, I see pink across 42% of each box, except for the participant repeated measures one. This pink represents my current subset, while gray represents the rest of the data, which in this case are the controls. Looking closer, I can see that my participants box says that I've selected 9,439 participants out of the 22,567 total participants. This matches my selection down below. If I look at the other boxes, I can see that data was also collected on households and samples. Looking at these sample size numbers, there appears to be 1 participant per household and 1 sample per participant, or over 22,000 measurements of each. The presence of households and household repeated measures indicates that some data about the participant's household was collected only once, but other data was collected at more than one time point, which we group under repeated measures. Based on the fact that there are over 43,000 household repeated measures, it seems likely that each participant's household was visited twice, which we can double check by looking at the household study time point variable below. Similarly, we have participant repeated measures. Clearly, there's a longitudinal aspect to this study with data collected at multiple time points. Moreover, you can see that the pink line in this box extends further than 42%, suggesting that data was collected more frequently on the cases than the controls. So to summarize, you can use the dataset diagram to see the shape of the data and sample size, and also view the impact of your subsetting. Now let's finish looking at what percentage of kids with diarrhea had rotavirus. There are multiple ways to look at this, including by going back to the rotavirus variables in the Browse and Subset tab. Instead, here, let's check out the Visualize tab. Clicking on New Visualization opens a menu of commonly used visualization tools like histograms, bar plots, and line plots. Let's make a bar plot of rotavirus presence and absence. I want to set my main axis variable to something related to rotavirus, so I can search for that term in the search bar. If I collapse the featured variables section, I can see a number of rotavirus variables. However, many are grayed out. This is because in a bar plot, the main axis has to be a categorical variable. And sure enough, something like rotavirus by TAC result has a mini histogram beside it, indicating it's a continuous variable and not usable here. You can move this slider to only show compatible variables, and then the list will be restricted to categorical variables or continuous variables with less than 10 values. I want to plot the prevalence of rotavirus, so let's click on Rotavirus by ELISA. The computation is done on the fly, and I get this custom plot. Note that these tools plot your data subset, or in this case, just the data for cases, the kids with diarrhea. There were over 1,700 kids with diarrhea in this study that tested positive for rotavirus by the ELISA test. I can change the y-axis to show a proportion instead of a count. Now I see that 0.18 or 18% of cases were positive for rotavirus. Let's ask our next question of how prevalence varies across study sites. You can stratify this plot by adding an overlay variable. Let's overlay this plot with the country of the participants. We can see some differences in rotavirus prevalence by country. Almost 30% of cases from Mozambique are rotavirus positive. We can give this graph a name of rotavirus by country. If we minimize this graph, we see that it's saved in this space. With just a few clicks, we were able to answer a couple of basic questions we had about the prevalence of rotavirus in kids with diarrhea and how that varied by study site. Now let's address our final question of whether this study has potential risk factor variables that I am interested in. Going back to the Browse and Subset tab, I want to look for variables related to water usage and hand hygiene. I don't see any in the Featured Variables section, so I'm going to collapse that. But first, I'm going to star this country variable because I want to be able to find it easily later. The rest of the variables can be found in this tree below. There are a few major categories which match the ones in the diagram above. Variables are further categorized within. Under household, for instance, we can see variables related to geographical location, dwelling characteristics, and so on. Since I'm interested in water usage, let's check what's in household water. Now let's look at the numeric variable water trips per day. You can tell it's numeric before clicking based on this histogram icon. Here, we see the simple human-readable label that ClinEpiDB has assigned to this variable. The original names of the variable in the dataset are given here. We also often provide a definition based on the codebook. Over to the right, you can see that 58% of households have data for this variable. This can help give you an idea of how much data is missing. In general, you can think of the Browse and Subset tab as an interactive codebook that lets you view and subset data in addition to providing basic information about each variable. I should point out that ontologies underlie our data integration. What does this mean? Another study collecting data on the number of trips to fetch water each day may have given the variable a different name. However, we map it to the same ontological term with the same label, so you can know that this variable is capturing the same type of information across different studies. The univariate distribution of numeric variables is represented using a histogram. We provide summary statistics at the top. Here, the household reported making anywhere from 1 to 57 trips for water each day, with an average of 4.2 trips per day. When we look at the histogram, the x-axis gives the number of trips for water per day, and the y-axis represents the count in every bin. At the moment, a bin is 3 days, which I can change to 1. If I want to know the number of households that reported 2 trips per day, I can mouse over the tallest pink bar and see 1,319 households of cases reported 2 trips per day. If I mouse over the gray portion, I see that 2,763 total households, so representing both cases and controls, reported this. I have additional options that allow me to zoom into certain parts of the histogram or change the y-axis to a log scale down here. If I wanted to subset data based on a continuous variable like this one, I could enter a range, say 1 to 3 in the box, or click and drag my mouse over the range of interest. Each filter I add appears as a chiclet with the variable name. If I mouse over, I can see the values that are being filtered on. Since we found a water usage variable of interest, I'm going to star it for later. I could keep looking for variables by expanding categories and looking at variables within them, but remember that GEMS has almost 600 variables, and I'm interested only in ones related to water usage and hand hygiene. Let's try using the search box to find other variables. If I start typing the word hygiene, I see a category with a few variables. Let's look at usual hand washing. Note that this icon tells us it's categorical before we even click on it. Here, the frequency table and bar chart tells us that 75% of households in this study use water and soap for washing their hands, and 23% use water only. If I look at the subset column, I see slightly different numbers, with 66% using water and soap and 32% using water only. Remember that this is among case households which collected water 1 to 3 times per day. If I remove the water trips per day filter by clicking this X in the chiclet, now I see that 76% of case households report using water and soap, and 23% report using water only, which is very similar to the numbers for everyone, both cases and controls, in the column to the right. This is represented visually in the bar graph here. Let's star this variable too. When we have a group of related variables with the same possible values, often collected on forms as a check all that apply, we present them as a multi-filter with this icon. Let's look at when washes hands. This group of variables asked whether people in the household wash their hands before or after activities like eating and defecation. A quick scan of the data shows that people are most likely to wash their hands before eating. Let's star this as well. In just a short period of time, I was able to find the data GEMS collected on rotavirus, figure out using visualization tools that 18% of kids with diarrhea had rotavirus, see that rotavirus was most common in Mozambique of the multiple different study sites, and find other variables of interest related to hand hygiene and water usage. Now that I've starred all these variables, I can use this toggle to quickly shorten my list of 600 variables to the few that I'm interested in. You'll notice that this toggle is available in the parameter selection menus in the visualization tools, as well as in the modal that helps you download your subset of interest, which you'll see next. In case I want to save this analysis, which includes the subset of cases only and a plot of rotavirus by country, I can give my analysis a name and add notes about it. It's automatically saved in the workspace under My Analyses. If you're navigating ClinEpiDB as a guest, then the analysis will be lost when you close your browser. However, if you log into your ClinEpiDB account, the analysis will always be saved in your account until you delete it. You will also have the option to share it with others. Making a ClinEpiDB account takes less than a minute. To do so, just use the link in the top right corner. How to download data from ClinEpiDB. Let's talk about how to download data so you can work with it on your own. Datasets on ClinEpiDB have different levels of data access since the study teams who share their data always retain ownership and decide the level of access restrictions. On the Analysis page, access level is noted on the View Study Details tab and also on the Download tab. If you want to get an overview of data access levels, you can navigate to the Study Summaries table and look at the column called Data Accessibility. Let's sort by data accessibility and look at the different levels. Some datasets are public, meaning that anyone is free to download the data, even as a guest. For example, the PRISM isomer cohort dataset has public data access. You will see a note on the Download tab of this dataset that says, "Data downloads for this study are public. You can download the data without logging in." Some datasets are controlled. You have to sign in to your ClinEpiDB account and fill out a data request form. This data request form may ask you a few questions such as the purpose for which you are requesting data, your hypothesis, and your plans for data analysis and dissemination of results. Once you fill in and submit this form, you will be allowed to download the data immediately. The purpose field that you fill in will be publicly displayed in a table on the View Study Details tab to help the study team keep track of requests and to promote collaboration between researchers with similar interests. Some datasets are protected with more stringent requirements. For these datasets, you will have to fill out and submit a data request form. This will be forwarded to the study team to review and approve, and our team will notify you when you are granted download access. In some cases, we may write back to you and ask for more information about your data request. This approval process generally takes 3 to 5 business days, but it may take longer at times. You can always write to us at help@clinepidb.org to check on the status of your request. Once you have access, our Download tab allows you to download either a customized subset of data or the entire dataset. Let's start by looking at how to download a subset of data. You can customize the observations or rows in the data by filtering via the Browse and Subset tab. For instance, if you select data from only the 3 countries in Asia, you see that in the Download tab, the number of households, participants, samples, and repeated measures are reduced to only include data from the countries you selected. If you want to download participant-level data, click on this link to open up a modal. The first step is to select the variables that you want to download. Key identifiers, such as participant and household ID, are required. You can then look through the variable tree to select all or a desired subset of variables. As you select variables, you see them appear in the table. Once you are satisfied with that table, you can click on this button to download the data. It will be saved as a text file, and you can open it in programs such as Excel, SPSS, SAS, or R. If you want to download the entire dataset, you can use the links under the full dataset. The README files give you useful information and tips for working with the data. Use key identifiers such as household and participant ID to merge files as needed for your analysis. This completes our tour of the ClinEpiDB workspace. For more help with ClinEpiDB, please write to us at help@clinepidb.org. You can also find helpful tutorials under the Help drop-down menu in the header. To keep up with our webinars, announcements, and releases, follow us on Twitter at ClinEpiDB, or just keep an eye on the right sidebar of our homepage. Thanks for watching this video.